Alright, time for another draftphysics.com, debatephysics.com, also video presentation. Oh, fighting the evildoers of conventional physics, these arrogant twats, okay, yeah, we'll do the British version too, who, pretend they have all these little secrets and they know all this little stuff and they're going to teach everybody else how it works. And they have no clue, really. I mean, they're just full of delusionary mush. They're just telling you Jesus stories, and that's all it is. Bunch of fables. Okay, physics fables. And so I'm going to combine two videos in one here just because it's convenient to do so. So, math and science guy who was a NASA engineer of some kind, who knows, doing what, made a video on gravity again, and it's inane, silly, stupid, so poor in terms of even the logic of it. It's so redundant and like he's talking to 5-year-olds, you know. And then he'll go and make a calculus video. It just doesn't make any sense. Your audience is either 10-year-olds or it's, 50-year-olds, but, pretending you can talk to both of them with the same gibberish. It just doesn't make any sense to me. All right. And Steve Mould, who also doesn't understand that gravity is a time-dependent force, doesn't understand that, frankly, you have to conserve momentum. That it's a momentum verse. It's, comes down to push, but it's the same deal. It's a universe full of force, and the force is applied to objects based on their mass, how many bits they have to collect the force. And, well, anyway, then there's no such thing as inertia. That's going to come up here, and all of the other mush they make up. All right, so leave us continue. So we're going to play some of this video by the math and science guy, Jason something or other. And it's, it's flat earth stupid. That's, I don't know how many ways. I mean, it's cartoonishly ignorant.
Now, curiously enough, even though the force of gravity is pulling down on this nickel more than 2 times the amount of force as what is acting on this penny.
So he's first, this argument that it's pulling down, pulling with what mechanism? What is a pull mechanism? And then the idea that somehow the force is greater on the nickel. There's no greater force. So it's just so stupid that they still haven't figured out the simple idea that, you're not moving people. You're not moving chemistry. You're not even moving atoms. You're moving electrons and protons. They're the things that have to be moved. They're the things that have to accept a velocity. That's the elemental universe. The real only universe is the one where electrons and protons are being pushed around by charge, okay, and the rest of the discrete force in the universe. And so every time you drop something, all you have to do is understand it to be a certain density. So it doesn't matter on its size. It matters on how many electrons and protons it's made out of. And all the electrons and protons are going to react to a wind or a force exactly the same. They're all the same mass. They're all going to move exactly the same. So when something's falling, there's not more force. There's the same amount of force differential. I would argue it's kind of obvious that it's just a force differential. There's less coming from the bottom, whether it was light or wind or water or anything. There's less of it coming in one direction, and there's more of it coming in the other direction, and you're just going to collect the differential. And the only thing that's going to do that collecting are your electrons and protons. If I put an electron and proton outside of you, it's also going to fall at the same speed because they're all the same size sails, so to speak. They catch exactly the same amount of wind and are moving the same size boat. And yes, when you tie a whole bunch of the little boats together, then you can create something that will catch more wind in total, but it's not going to move any faster. It's just going to be this collection of boats when it hits the shore, is going to be able to apply more pressure because it caught more wind, because it has more sails. That's it. And it has more mass to its boats because it has more boats. So getting squished by 4 elephants is more elephants than 2 elephants or 1 elephant. Just because they've all collected a force, and now the force, you're going to collect all of their force. So you collect all the force collected by all these boats in one case, and you collect just the small amount in the other case. But the rate at which they fall and the rate at which they collected was exactly the same, and the force applied to them was exactly the same force. There was not more force applied to the heavier object. It just collected more force. It's a really important distinction. So, yeah, I think that's simple enough. I think you should be able to understand that, yes, that model works perfectly. Okay, the idea of thinking about gravity as rain and thinking about mass as a bucket, and it's just about you only collect it in the bucket. The bucket can only collect more when it's not on a, some other contact with some other surface. If it's in contact with some other element, the bucket drains. But as long as it doesn't have contact with something, the rain falls in the bucket fills up with the rain. It's about how long you're in gravity decides how much gravity is going to affect you. You have to be exposed to it. It's just like getting suntan. It doesn't matter if you walk around the yard and jump up and down and speed going side to side. It just matters how long you're in the sun. And you can't outrun it because the force is going the speed of light. So it doesn't matter whether you're running away from the sun. It's not going to make any difference because it's going so much faster than you are that you can't make it less because you changed 10 miles an hour. In a million miles an hour, 10 miles an hour is just too irrelevant. So you can't outrun the force. And you can't technically, you can't really run into more of it much either. But anyway, leave us continue. It's just wrong. So he's going to go through 59 examples of different masses falling the same. So we'll skip over some of that, but I'll just show some of it because it's just, who are you talking to? Like we can't get it from the first example? So it's like, you drop a feather and a hammer, done, right? We have figured it out. Okay, air resistance has an effect. If there's no air resistance, all mass falls at exactly the same rate in gravity. Done. This isn't complicated. And, and the reason why is quite, in my opinion, quite obvious, because the stuff that's really moving are the little bits that make it up, and they're all the same.
It turns out that they hit the ground more or less at the same time. Of course, one hit slightly before the other, but that's just because I can't drop it perfectly.
Yeah, right.
Also,
so
the angle of that camera is a little bit tilted, so it may not look that I'm holding them left, even reading on the scale. So
paper
whatever.
Clips, then he does dimes, 14 forks.
No matter if they have differing weights. Okay, 3, 2, 1, very spread out in time. In order to demonstrate that, if I take the same 2, 1.
I mean, we all got it, right? I mean, does somebody not get this
point? A feather
point?
has a very large...
And again, you're going to bother tomorrow doing a video about calculus or something very complicated, and you're going to think the same audience is going to be able to appreciate both those videos? No chance. I mean, either make videos for kindergarteners or make videos for adults. But making it for both is irritating. All right. So here's the anybody who's had any exposure to physics has seen this clip of dropping the hammer and the feather on the moon. We all get it already. I mean, it's just so annoying. Then he gets bigger and bigger, gigantic steel balls, and you're just saying, well, if you have these gigantic steel balls, you ought to collide them into each other, okay, and try to demonstrate your theory that you can make free momentum. Smash little things into the big thing and see if you can make free momentum. All right, so that's all he does here. He just keeps doing this crap. Then he drops a dumbbell. I mean, the whole thing is just such a waste of goddamn space. So then he uses a toy to do another experiment that's already been done 1,000,000 times. I mean, you know, the fact that things drop the same speed, you shoot the bullet, you drop the gun at the same time, the gun will hit the ground at the same time the bullet will hit the ground, except for the fact that if you shoot it very, very fast, it won't hit the ground at the same time because the Earth is curved. But whatever. No, he didn't get into the whole curvature issue. He even said on the moon that this will happen, and I'm saying, well, the moon has a higher angle, you know, smaller circumference, so it's a little bit easier to actually get yourself into trouble when you travel a bit of distance. You're going to have a longer way to fall, so they're not going to hit the ground at the same time because one of them's going to start orbiting. So somewhere in here he does the same, makes the same line that there's more force, blah blah blah. All right, so let's just get through this stupid little toy stuff and
actually happens this way.
See what we got here.
It works this way because no matter how much horizontal velocity you have, gravity is always acting in the down direction.
Yeah, and the trick is that pieces of matter, unlike photons or other force bits, matter can have more than one velocity. You can give it this velocity, and then you can hit it that way at the same time, and it'll go this way, because it's going to be going this way and that way. Giving it a new velocity in a new dimension doesn't kill the old velocity in some other dimension. So technically a piece of matter can have velocity in 3 dimensions. It can be going this way, it can be going that way, and a little bit that way. Fact. Where force, a photon, one-dimensional, can only go in one direction. Can't go this way and move that way. Can't do it. Creates diagonal lines that are longer distances. Can't be done. All right, someone in here says it again, so we'll just find the part where he says it again. Oh, he does this outside crap. I mean, this is just cartoon physics. Just so bad. I don't know why. I don't know why they do this.
Not only do any two objects with differing masses hit the ground at the same time, even though one is being pulled down harder.
So he said it again, right? It's being pulled down harder. It's not being pulled down harder. That's why it moves exactly the same speed, because it's being pulled down exactly the same amount. And the fact is it's being pushed down. All right, and that's the absolute fact. Push is a real thing. Pull is a fable. That's neutrino warp drive stuff. It's just fantasy, fable, bullshit. The reality is it's a push averse, and the fact is you're in a push differential. There's more energy from the universe hitting you from above because there's nothing in the way than there is from below, because there's a big giant hunk of matter that's consuming the force and heating the earth. God, people are just so... I'm sorry you're all so fucking stupid.
But if you take one of the objects, either one, and throw it horizontally, it will still hit the ground at the same time as an object dropped from a...
Right, so the real point here, I'm just arguing, is that his whole argument that there somehow is more force, and then he's going to use this word inertia, so that's going to be coming up, so we'll wait for that.
Stationary point of view, no matter how fast horizontally it has traveled. Theoretically, even firing a bullet and dropping a bullet, they will theoretically hit the ground at the same time, although air resistance obviously changes the result. On the moon...
Right, so it won't work because the fact is the Earth is curved, and if you shoot a bullet at a high enough speed, and that curvature will mean that they won't hit the ground at the same time.
They absolutely would hit the ground at the same time. Now, the executive summary as to why this happens is that there are really 2 kinds of mass in physics, really. One of them is called the gravitational mass. That's...
All right, so there's only one kind of mass, and it's electrons and protons. They're the only things that give you mass. Now, conventional physics says electrons and protons don't equal your weight. Okay, but that's just because they haven't weighed electrons and protons correctly. They used 1/2 mv squared to measure the mass of an electron. So you can imagine if 1/2 mv squared is a fably rubbish pile of crap, that obviously their measurement of the weight is crap.
The mass in grams that we use to calculate the force of gravity. And then we have another kind of mass in physics which governs the inertia of the object.
So there's no inertia, and he's going to use the key words here again. So physicists keep saying that matter resists being moved. It doesn't resist at all. It just says, you have to give me the energy to move. If I don't have the energy, I'm not going to move until somebody gives it to me. You have to share what you have and let me have some of it. If you don't share what you have, if nothing shares energy with me, I can't go anywhere. So something has to move me. I have to, it's like it's money, and you're saying, look, I got no money. If nothing gives me money, no force gives me money, no other object gives me money, well, then I'm going to stay poor. Duh.
How hard is it to get an object moving? And that
So there's no hard to get an object moving. The only thing you have to figure out is that, well, if you have 1,000 people and you're going to give them blueberry pie, they're all going to get a very tiny sliver of pie. They're not going to get very much. So big objects, it looks like they're, it's moving kind of slow. Well, it's moving kind of slow because you didn't give them enough pie. You got to spread it to all of the mass bits, have to get the little pieces of energy. And it all has to be shared among all of them. So obviously, if you're going to give 1,000 people $10, well, they're not going to go, oh shit, I'm going to go run to the store with my 10 cents. No, they're not.
It's called the inertial mass. Now, we have two kinds of masses, but you probably are...
So now, just in about 20 seconds or whatever, 30 seconds, he's going to say exactly the opposite and say, in this universe, there doesn't make any difference. There's no inertial mass. I mean, it's just ridiculous gibberish.
Saying, well, I never heard of two kinds of masses. This guy's crazy. Well, it turns out...
You're obnoxiously arrogant is what you are. And I would argue that you're substantially ill-informed about the real universe because you've never really looked at anything to see for yourself, and instead you've just believed whatever your dopey teacher taught you. So you're just good at reciting catechism. You're really bad at understanding reality.
Out that in our universe, these two kinds of masses, which are totally different in different types of equations, they actually turn out to be the same quantity in our universe.
So what's the point? It's just delightful, right? It's a meaningless, pointless distinction. There's absolutely no meaning to the word inertia. It doesn't mean anything. It just means there's a mass. You're going to have to, it's an amount of bread, and you're going to spread your 1 jar of peanut butter over it. How thick the peanut butter is your velocity, and it's just that simple. If you don't give enough peanut butter, then you're not going to be spreading it very thick.
The gravitational mass, which governs the force of gravity, and the inertial mass, which governs how...
The gravitational mass, which controls there's no controlling. Gravity is just a fact. There's a stream of energy, and there's a differential between the two sides of that equation. The earth, what's coming out of it, and the sky, what's coming down from it. And it's just so kind of obvious that, the raw energy is up here and the diluted energy comes from below. Duh.
How hard it is to get things moving, how much inertia it has, are the same quantity for our universe and with matter that we...
Right, so what's the difference? So you're just playing with words to confuse people, and that's it. These words don't have any other purpose than playing some game and calling some organ, some fancy word to confuse people instead of just calling it the pumper thing. Yeah, just keep it simple. The filter, the pumper,
can interact with. And because of that, any two objects will hit the ground at the same time.
So that's just the nonsense. Okay, they hit the ground at the same time because the actual force is exactly the same on all objects, and the only thing that can change is you can have more objects to move, and when you move more objects, then when they finally hit something, they're going to have collected more motion in the form of force.
Because even though you drop the two objects, the heavier object is being pulled down harder.
It's not being pulled down harder, so it's just nonsense. It's collecting more energy. More rain is being collected because it has more buckets. It's that simple. And when it hits the ground, what's going to matter is what's the total amount of rain you have collected. That's what's going to decide how big a splash there is.
That is true with a higher force, true.
It's not true.
But that object that weighs more, that has more mass, also has a harder time getting started because it has more inertia.
Right, so it's not a hard time getting started. It's, again, just the simple truth. They're all going to move at the same speed, so where's the evidence of the harder time getting started? So we just said it has a harder time getting started. It doesn't have a harder time getting started. It's moving exactly the same speed. So what are you talking about? The only fact is when it hits the ground, it's going to make a hell of a mess because of the fact that it's collected more force, and that's it. But the collecting process is identical for the elephant and the mouse. Their atoms, their electrons and protons are doing the collecting.
So it's being pulled down with a greater force. This bar...
You said it again. So there's no greater force. It's a stream, same current. It's a wind, same exact wind. And all you're saying is that you can have a lot of boats, okay, with a bunch of sails, or you can have one boat with one sail. And then you can say, well, when they hit a pier, which one is going to be capable of doing more damage? Well, the whole bunch of boats that are going to hit obviously are carrying more wind pressure that they've collected, and the one boat only has that one unit of pressure it's collected. So that's the only distinction. It's just gang warfare. If you have more people pushing on the door, then the door is going to yield.
Bell is being pulled down with a greater force, but when I let it go, it is more difficult to get this thing moving.
So it's obviously not more difficult. Right? He's just proved that it falls at exactly the same rate, and then he says it's more difficult to move. Well, it can't possibly be moving the same exact speed if it's more difficult to move. This is gibberish, okay? This is not science.
Than a marker. This marker is being pulled down with a less force of gravity.
Right, so it's the same force, same stream, same wind, same stuff to take, and it's just the bigger mass takes more. It consumes more of it. More of it is collected because there's more mass to collect it.
But it is easier to get moving. And those...
So nonsense. So easier to get moving, not in gravity, but yes, if you're going to push it yourself, and you only have to you only have to have enough wind to push one little boat, that's really easy to do. And if you have to push 500 boats, well, you're not going to produce enough wind to push those 500 boats at the same speed. But gravity has all the wind in the world.
Two ideas cancel out. So even though this is being pulled harder, it's more difficult to get it moving.
It's getting pulled harder, and it's going to move exactly the same speed, which means it was just as easy to move as the other object. Move just as easily.
And this guy's being pulled less, and it's easier to get it moving, so they cancel out exactly, and the two objects always hit the ground at the same time. Now,
so complete nonsense explanation.
How did it work when we were shooting the bullet? The thing you got to remember is that...
All right, so this, we've already been here and done this about 6 million times, so not very interesting.
Because gravity is still pulling it down the same...
So again, it's pulling it down, pulling it down. This is their only narrative. Will never realize or accept that, well, yeah, I mean, it could be, it's a push. I mean, there's nothing in Einstein's theory that says it must be a pull. So let's just understand. It doesn't say that. But they just go there. Why? When pull can't be elemental. Elemental pull is voodoo or witchcraft. It's some sort of mystical religion kind of thing. religious characters could pull things, okay? Jedis, but not real science.
Same amount of meters per second, and it hits the ground at the same time. All that's going to happen is the motion, instead of being a straight line as it would be in space, it's going to begin to curve down because gravity is pulling it down a little bit each time.
So I don't know what space he's talking about. You have to be away from all gravitational objects to actually not have your trajectory influenced, which is pretty rare.
I hope you've enjoyed this. I hope you've learned something. I encourage you to grab objects and start dropping them.
Yeah, whatever. You're just putrid. Arrogant slop. They're so unaccountable, okay? I mean, they will not be challenged. They will not respond to the challenge. It's just so obnoxious. Yeah. All right, so take a pause, and I'll do a little bit more for that Paul guy who isn't going to pay any attention anyway, because he's one of them. He says things that are impossible. So maybe I'll read one sentence. I mean, I'll probably do all the email that I did, because it just demonstrates how they just keep avoiding the subject. But now he says that he agrees that Stephen Mould is wrong, because Steve Mould wasn't saying that you can conserve both kinetic energy and momentum. So the half mass can go both, twice the speed, and 1.4 the speed. It'll do both at the same time. I didn't make this up. He said it. That's his response to me. After all this discussion about this stupid kinetic energy theory and momentum, his response is they're both conserved. How is it possible? Levers can't conserve both. The outcome is one or the other. It's either going to, the half mass is either going to go 1.4 or it's going to go 2.0, but it's not going to do both. I mean, fuck. It's just so... Oh, God, this is so irritating. All right, I'll pause. All right, back. So, in one of Paul's arguments, Nord guy, he's using this ramp argument, that something rolls down a ramp and then has a velocity, okay, that's commensurate to the falling velocity at that height. All right, but the trick is for every object you do this to, they're going to roll down this ramp differently depending on how their mass is configured, because they're creating a bunch of angular momentum. So the object's linear velocity when it leaves will not be its total momentum. It'll just be one component of its momentum. So if I have a big heavy steel object, okay, that's going to have, especially if the weight is on the outside, all right, and it's going to have a higher and higher velocity, well, the object's going to take longer to get down the ramp, as it has to collect enough energy, okay, to justify the momentum its rolling will involve or create. So this is a lot like the suspending a weight, okay, over a pulley, and then saying that this falling rate is always the same, regardless of how fast the weight falls. I don't know why that doesn't show up. That is interesting. A little shadow there, you see. Get rid of it. Well, whatever. Can't get rid of it. Anyway, stupid light bulb. Yeah, I can get rid of it that way. Well, I got rid of everything that way. Anyway, just doesn't really matter. We'll assume you can follow along. So the slower the weight falls, the more energy. Oh, I knew that was heating up. My bad. Anyway, smoking my cigarette. Oh, gotta go fix it. All right, rough day. Anyway, so So there's going to be two things that are going to be a factor in terms of what you're going to get by rolling the object down this ramp. And it really does matter how much mass it has. Okay, the velocity is going to be the same. The linear velocity of all the objects will be the same. But the amount of energy held in rotation will be different. And so the heavier the mass, the more stored energy in the rotation of the object. And so you can understand that even when you're throwing it off a cliff, yeah, it'll go off the cliff and do its linear velocity will be recorded. So it'll always seem like the same energy, but it's not the same energy because depending on whether it's a lead ball or a tennis ball, the lead ball is going to hit the ground with, its rotational energy still intact. So it's still going to be spinning. So when it hits the ground, there's going to be motion besides the impact energy from gravity, besides its linear motion. It's going to be spinning, and the spinning is going to throw stuff also. So you have to account for that. And so if I hit it into a brick wall, then I'm testing its real, how much energy it really collected. I shouldn't roll it and see how far it rolls. I should roll it into a spring and measure what's its impulse energy. Okay, its impulse energy is all that matters. What do I collect? Because the rolling object will convert, okay, the rolling motion will be converted into motion in the same direction as the linear speed of the roll because of the way it's going to hit the surface. It's actually going to be pushing down quite a bit, but technically it's going to at least convey some of it. Ideally, you put the wheels on a cart because that way the cart will do the conversion. It'll take all the energy from the wheels and plow it in one direction. You could see it does that. See, doesn't matter which way this is going here. Doesn't matter whether the energy is going up, down. Doesn't matter which way you think of it going because it has to go this way when it hits the wall because it's connected to the cart. And so all the angular rotation will have to go into one direction. So anyway, it's another gimmicky kind of experiment. I mean, it doesn't prove anything at all. Instead of showing us it taking 25 times the fuel to go move something 5 times as fast, they keep playing games with these little rickety experiments that have 4 million variables in them. And again, the variable of angular rotation, angular momentum, is essentially the same as a flywheel on the cart. So you have to think of the wheels or anything round and think of it as an extra flywheel and understand that, yes, the energy of the flywheel counts. So as the object's moving, the flywheel is spinning. Okay, I have to remember that flywheel energy also has to be included as part of the energy collected. And it's going to increase when you test it, you have to collect both the linear motion and the motion caught up in the flywheel, the angular momentum. But they cheat. All right. So let's see. Maybe we'll do some comments. I don't think there is much, so I'll go see if there is anything worth responding to. All right, I think all there is this one dopey comment. So, physics fellow, I doubt it. I guess I should go see if he has any content on his channel. No. All right, so it's just a blackboard with the word physics for an icon. So, it doesn't seem very physicsy if you don't even talk about physics. Have you ever considered that there may be significant and fundamental reasons physics disagrees with your statements? Well, I'm just saying, where's the disagreement besides them saying I'm wrong? I mean, there's no credible disagreement. You can't make the argument and say, okay, you don't have to answer. You don't have to show me it taking 25 times the fuel to spin something 5 times as fast. I'm saying you absolutely do have to show me that, or you're just talking shit. I mean, it's a dramatic statement to make against all reasonable intuition to say that it takes 25 times the fuel to go 5 times as fast. It's absolute nonsense. It's outside of any human's experience. So you really do have to show me, and you won't do that. All right. in the lever example, your statement breaks the law of conservation of energy. So it's an absolute lie. We know the law of the lever is what I'm defending. I'm defending Archimedes. I'm defending the simple truth that you just take the distance and multiply it times the mass, and the two sides have to be equal. That's conservation of momentum. That is conservation of momentum. Jesus. Twice the distance, twice the velocity. 4 times the distance, 4 times the velocity. 6 times the distance, 6 times the velocity. That's the absolute truth. All right. You state what you think should happen. Perhaps you should try it yourself before making declarations. So again, I have done some of these experiments, and again, the balancing, perfectly balancing gravity balance with a 4 mass, 1 distance, and a 1 mass 4 distances going 4 velocity, perfectly oscillates for 100 times. I'd say it's a decisive piece of evidence. And so where's your debunk of it? Where's your explanation for how it isn't a decisive piece of evidence? You didn't produce anything. So, and I pointed out, well, look, Mythbusters did do car crashes, and the car crashes showed no evidence of kinetic energy whatsoever, not even an inch of it. Nothing. Absolutely nothing. Twice the speed, twice the damage. Nowhere close to 4 times the damage. So there are pieces of evidence, and they're just pieces. And the whole argument is you've been asserting this crap, okay? 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. You've been asserting it for over 350 fucking years, and you have produced no physical evidence that it's true. And then you claim we have to do something? I have to do something? I'm saying yours is shit science. It's just a religion because you won't produce any physical evidence. All right. Can you provide any links showing evidence to cite any reference that support your statements? Yes, all of my statements are supported by the fact that I just plainly draw the circumstance and state the things I have done and the things I haven't. Okay, but I have linked to other things that are done. I'm just saying when I reference Archimedes and I reference the fact that levers are explained this way over and over again, that somehow they're a useful tool. Well, they wouldn't be very useful if they didn't conserve the momentum. And I use the illustration of the gun and the bullet. I point out what every ballistic pendulum proves, is that you can't collect the kinetic energy. Ever. You can never collect more than the momentum. A glaring example, a glaring proof. I don't have to do any more than that. You have to prove some element of your theory, and you've proved none of it with any evidence. Any credible evidence. Denting clay, okay, with round objects is silly. All right. There may be a significant and fundamental reason physics disagrees with your statements. That was his statement I responded with. Unfortunately, you can provide no credible experimental evidence to defend the reasonableness of your physics. Fact. Okay, he says, in the lever example, your statement breaks the law of conservation of energy, which is just a lie. Okay, the 2,000-year-old law of the lever does not say you conserve kinetic energy. It says you conserve momentum. Absolute fact. All right. You state that you think what you think should happen. Perhaps you should try it yourself before making preposterous duplicity. You don't have to prove your God exists. I have to prove he doesn't exist. Fact is, I have done experiments. I have cited experiments that prove kinetic energy nonsense, and the simple gravity balance is a decisive proof. So we'll just go over and over this. So he doesn't pay any attention to anything drawn in the video or stated in the video, and he just cites this crap as if there's an argument here somewhere with some piece of evidence, and there's no zero evidence once again. Can you provide any links showing evidence? I've done so. Can you provide any evidence showing an actual experiment demonstrating it takes 25 times the fuel to move or spin something 5 times as fast? I'm going to keep saying it. It's a glaring deficit in your argument that you can produce no evidence. Okay, perhaps just show an actual lever not conserving momentum. Yes, please, show me a lever failing to conserve momentum. All right, and he types some more crap here. Thank you for the reply. Fuck you. I did leave a lengthy reply addressing all of your secondary statements, but it appears not to be showing. Well, then I guess you should try little pieces of it at a time. Anyway, I will keep this reply a lot briefer. Yeah, right. There's no reply. This is an argument about evidence, and until your science produces some evidence, I'm going to keep saying it's unevidenced fable. There's absolutely no good reason for me to believe in Sasquatch. You're saying I should, and I'm saying, fuck you, show me. All right. Do you have any background in physics? Totally irrelevant. I mean, so I should just block you for that. All right. My arguments stand on their own. You have to counter them. It doesn't matter who makes them. The messenger is irrelevant. The arguments matter. Can you pay attention to the subject of the video? Oh, fuck. I have to ask, as it means as you seem very muddled in your physics concepts and terminology. Well, you seem like somebody who shoves centipedes up your butthole. You know, that's what you seem to me. Yeah, and you like it. Okay, you are making an extraordinary statement. No, you are. You fuck. It's just amazing. You know, I'm defending evolution. I'm defending the theory that there are pieces of evidence that fits my theory. There's no evidence that fits yours. No credible evidence. Again, denting clay with round objects is as stupid as shooting arrows and saying the pointy one went further into the object, therefore the pointy one has more energy. That's how bad your science is. All right, Steve, can you break the law of energy conservation? So he keeps saying energy conservation when it always never is conserved. They admit that energy is not conserved. Professor Lewin says nature can deal with kinetic energy one way or the other. Nature cannot finagle momentum. So just keep lying about the state of physics and what physics actually says. Momentum is the thing that needs to be conserved more than kinetic energy. Lots of experiments, kinetic energy isn't conserved. There should be no experiment where momentum isn't conserved. All right, energy conservation. You state that you have an experiment to show this, and others have done it too. Please link to your own proof. Okay, I'm not going to do that. I've already explained. I've done the lever thing. I'm not linking you to it. I'm not here to personally tutor you, okay? I've made a ton of videos. If you don't believe that a gravity balance actually does say that a one mass going 4 velocity equals a 4 mass going 1 velocity, that's what absolutely happens, you fucking shit. And until you provide a single piece of evidence showing how that isn't true, or explain somehow how we have twice as much energy on one side as we have on the other side, fuck you. All right. The law of the lever concerns itself with forces and distance. It doesn't matter. The force, as Newton said, twice the force, twice the velocity. 3 times the force, 3 times the velocity. The force is velocity. Okay? Completely interchangeable. All right. Which is work energy F times distance. So you can keep telling me it's that, but there's no proof or evidence that that's true, that it gets correct answers. So again, just fuck you. Show me or shut up. Okay. The work you put in is equal to the work you get out. Not in kinetic energy, it isn't. Obviously, the gun and the bullet are a perfect example. Same explosion. The gun gets 2 joules, the bullet gets 2,000. Ludicrous nonsense. Absolutely doesn't happen. There's no such thing. There's no 2,000 joules. You'll never collect it. You'll never do work with it. So that's the absolute truth. There's absolutely no way to collect the 2,000 joules the bullet has. No way to collect it. Show me a single experiment where they actually collect it. Measure it. Fuel and motors complicate things. There's no complication. We all know what electricity is. We all know how it pretty much works. So spinning a motor, 1 velocity, then 2 velocity, you're saying it's 4 times the energy, 3 velocity, 9 times the energy, 4 velocity, 16 times the energy, 5 velocity, 25 times the electricity used. It doesn't happen. It's absolute nonsense. It doesn't happen in generators. It doesn't happen in anything. Okay? It's crap physics. It's garbage. You have zero evidence. Okay. Efficiency of the consider keep a simple mass, force, and distance will show very closely. So I'm just saying it doesn't show anything. Okay, Archimedes would have predicted that a half mass, twice the distance, will go twice the velocity. He wouldn't have had any doubt about it whatsoever. You're just full of shit. to say there's any science that changed that truth, that the law of the lever changed somewhere. It never changed. Okay, there's plenty of credible evidence if you take the time to search for it. So fuck this. I'm just blocking you. I mean, this is just bullshit. I'm not wasting my time with these assholes. Google it. No, you Google it and show me the results of the Google page. Fucker. Because it doesn't exist, asshole. I've spent 10 years doing this, begging for you to link me to your fucking evidence. I've said that line at least 200 times. Link me to your fucking evidence. And you can't do it because there isn't any. You lying sack of shit. Oh, God. Insufferable crap. Ugh. Might as well delete this. Waste of goddamn time. So really, don't bother commenting until you can link to experimental evidence. If you can't link to experimental evidence, just don't bother saying you're proving me wrong or you have some argument, because you don't. You have zero evidence, as Steve Mould proved. There's no evidence. He didn't do any experiment. He just declared it. He said it goes 1.4. Did he show a shred of evidence that indicates that actually happens, that levers fail to conserve momentum? No evidence whatsoever. That's your physics. It's just a lie. It's just a religion. You're just silly fanboys with fucking centipedes up your ass. God. Dorky perverts. God damn. Covered. The whole planet's just covered with them. Anyway, till the next time and such. Fuck this shit. You people really suck. You're just such fucking garbage.